Okay. All right. I'll I'll get this where it should be. Are you seeing it full screen out there right now? Right, the presentation. Okay. Okay. Trying to make sure I'm tracking all right here. Anyway, it's not working for me. Hold on. Okay, now I might be in business. So this was the app that I was telling you about. Do you see what looks like "Welcome to North Texas Microwave Society"? I see a nod. Okay, yeah. Thanks, David. Yeah. So this is the Rover app that I was talking about that Paul's just finishing, and it's pretty cool. If you're a rover, it takes care of some of the chores that you have on sheets of paper that are blowing all around the place. And here's our agenda again. We're gonna flip the technical presentation where Al will go first after the announcements, and then we have some show and tell in our business meeting. In the way of announcements, we had a donation made by MOTS KD5FZX of Nano VNA, and we sent this to Texas A&M IEEE. MTTS is what they call themselves, Microwave Theory and Technology Society. We are a sponsor of this group of up-and-coming RF engineers, so they were happy to get one. They already had one, but this would allow them to split their teams when they're doing network measurements. A donation was made of a used Directive Systems 1296 loop Yagi, and that was donated to Motz, who is working on his rover system. That antenna was originally owned by Craig Kilo Alpha 5 Bravo Oscar uniform. And then Motz has donated a MikroTik LHG 60 gigahertz endpoint, which is purposed for use in a new dedicated beacon monitoring system. I'll be showing that a little bit later, but it's just a backhaul component that would allow us to get data back into the NTMS learning model. A last item here, I presented on a millimeter wave propagation forecasting to the Bay Area Microwave Group on Tuesday this week. That meeting started 9 p.m. Central Daylight Time, and it was great to talk to those guys again that were with us in Tucson at Microwave Update. In Barry, it was an N9JIM, and Oliver Barrett, Mike Lavelle, K6ML, that group of folks that keep the candle burning out to the west.
Yeah, it's a good group, all right.
It's a great group, yeah. Al, you're coming up here for announcements. Would you care to step in here when you have a moment? What I can give you is a quick checkout. It's just going to be arrowed down right here.
Okay.
To advance. Okay.
Think I can handle that?
Sometimes we surprise ourselves.
Hey, good afternoon, everybody. Just a few notes here. Talked a little bit about conferences that are coming up. Of course, we just had the Southeast VHF conference in Macon, Georgia, and that was a good event. What really is nice about that is it's in the South, so a lot of folks that we might work on terrestrial modes are there. You know, and some notables like Steve Castro and Charles Osborne, and Ben Lowe was there. So it's just a good social gathering. I'm not sure exactly where it's going to be next year, though. And exactly a week after that, in April, was the Northeast Weak Signal Conference. And I really wanted to go to that one as well, but they're only 1 week apart. So I made a choice this year. And then we've got, at the end of May here, actually in a few weeks, we've got the EME conference. And in Tenerife in the Canary Islands. And, well, I sure hope the hantavirus doesn't create issues for us there. Hopefully those people that are coming in on this ship will get shipped out as quick as they came in.
Yeah, Reiner just sent something out on that, said, don't worry about it, it'll be fine.
That's what Reiner said?
Yep.
Okay. Well, I know the Americans are, they'll be in hazmat suits and they'll make it into a Tenerife and then they'll be airborne, back to the States is what I understand. All right, and moving on from there, what I've always found interesting is the Aurora Conference that the Northern Lights group has. It's a once-a-year conference. I've never made it, but I like following that group. And it's something that we've had a time or two in the past. We've had the South versus the North, South Texas versus North Texas, and we had a couple gatherings of that at the Presbyterian Church in Richardson. And I'd like to see us do that again. Have some larger, gatherings like that. Then we got Central States in end of July. Everybody know where Gerardo, Missouri is?
It's south of some big
Okay,
city.
all right. A few people. I always see signs on it for it as I travel on I-57, but in reality it's south of St. Louis and on the Mississippi. So that's going to be a different venue for Central States, and I think we're all looking forward to that. And another biggie is Microwave Update in Rochester, New York. This will be the third time that the guys up there have hosted it, and it includes guys like Dave Halliday, who a lot of you probably remember from down here, even though he's been gone for a couple of decades, it seems like. But they'll be putting it on up at the Rochester area, and they also have a nice radio museum up there, and we're looking forward to going on that. In fact, I think it's going to be specifically opened on Thursday just for us. So some fun things this year, good ways to spend your money. And of course, next year, Microwave Update will be in our hometown here, somewhere in the DFW area. And don't know exactly yet, but Jim and I'll be kind of orchestrating that and looking forward to some help from the NTMS guys like we had the last time. In case you remember, it was back in 2019 that we last had Microwave Update here. So it will be about 8 years. So that'll probably most likely be in October sometime. We try to do it after it cools off, but in 19, I was hoping for that, praying for that, and it cooled off a week after Microwave Update. So the timing wasn't very good on Mother Nature there. And this was just a slide that kind of suggests which local hamfests have VHF plus oriented sessions. And Cowtown, which has been going on for quite a few years, in January, we contribute a lot to that. NTMS does. And also the Orlando, I guess it's Hamvention, that's in early February. That has some good VHF sessions as well. And then there's Dayton Azenia, which is actually going on a week from this weekend. And there'll be some VHF sessions there. In fact, our very own K8ZR will be hosting that. So I'm sure he'll be looking forward to seeing a lot of you there. The Huntsville Hamfest has always been something we've wanted to go to, but it's just kind of like HamCom. HamCom is scheduled during a contest. Well, Huntsville Hamfest is always the first weekend of the 10 gig and above contest. So most of us, and hopefully will continue to stay on our home turf. Then I wanted to bring this up because DFW Ham Expo, this is what's kind of replacing HamCom, and it's a totally different group. Denton County Amateur Radio Club started it, and from what I understand, I was just reading on the website, they have their own organization, if you will, that runs it. So it's not really associated with any club other than say it's a DFW kind of sponsored event. And that'll be June 12th and 13th. The tailgating is only on Saturday morning. So 1 p.m. to 6 p.m. on Friday, and then 8:30 on Saturday for the indoor. And go to the website and you can read about it. It's going to be a very, very big event, and probably one of the biggest in Texas. I'm not sure what Houston has to compare to it at the moment, but I'll try to be there to support it. And it's usually hot. So when you get there at 7 a.m. on Saturday for the flea markets, you can't hardly wait for the indoor to open up. So we'll be there. But there aren't any VHF or microwave sessions. I don't think there are any sessions other than VE testing going on there. This is something I brought up before about a 122 gig workshop. I know there's several people in the area that have made contacts on that band. Scott and I and Paul and Jim. Paul and Jim have made some really good contacts over many kilometers. Scott and I, we worked across Lake Lavon, and that was about it. So we got some more work to do there, Scott. And in bringing this up, Tony, Kate, ZR, and I, we tried our 122 gig rigs at that Southeast conference, and I think both of us had issues. So we're going to do it at Central States, the Wednesday of Central States. We'll be up there in Gerardo with our same units.
Cool.
So if any of you have any interest in 122 or getting your rigs built up, I know there's several others around here in the area. I won't mention any calls, but you know who you are. We'd be happy to help you get those built up and tested. This is a list of the NTMS beacons. I think what's on the website is also as updated as this is. See, this is February 12th earlier this year. You can see the ones in yellow are, trying to remember what this was. Yeah, the ones over in Denton. And we've had some issues with some of them, and we need to get them worked on. And it's actually quite a bit of work. We were trying to go up there on January 23rd, but I think we had inclement weather then, so we had to put it off, and we have yet to reschedule it. But some things that immediately that we need to do is to work on the 10 meg reference for the 432, 902, and 1296. Something is modulating it. And it may be, we kind of use this in cahoots with the repeater system that's up there, or the Denton County stuff. And I know they were coupling off some of the 10 meg for something. I can't remember exactly what it was. But we do have a new Spectracom GPS unit that we're going to connect. And we probably will have to install a new GPS antenna because I don't think the old one is working. And of course, we got to pull a 3456 beacon because we don't have that part of the band anymore. We stopped at 3450. But we do have a new 3400 beacon built that will go in. And the 2304 beacon, it was really sad to see that one just kind of quit because it was quite a performer in terms of power and what it was covering. So I got to pull that down and we got to repair it. And then, as you'll see in the next slide, I'd like to do something to try to move the beacons closer in because we're not as young as we used to be. And this is where the beacons are mounted. Kind of a nice view. This is off, looking towards McKinney, about 280 feet above ground. Where the beacons are is only probably 15 feet above the top of the dorm. So it's not like you're looking down 280 feet, but you're out on it's like scaffolding out there. And you really have to bring a piece of plywood so you can sit on it. Otherwise, that doesn't feel very good on the you-know-what. But I'd like to move the beacons in a little bit closer. I know we had them, they're probably 8 feet out from an area where you can stand. And I'd like to get them in a little closer just so we can more easily work on them. But you can see on the left there is the 2, 3, and 3, 5, and 10 beacons. In the middle there is the 2304. And On the right is the at the top is the 432 Halo, and boy, it's been so darn long. I think it's sitting on a 902 1296 slot antenna. Terry Turner built those when he was around, which was a long time ago. So we're trying to plan that. It's really hard to get access to the dorm. West WA5TKU has to work with Gerald of the Denton County Amateur Radio Club to get time, and it's getting a little difficult to coordinate that. Plus, they want to have some guy up there holding your hand while you're up there, which is really difficult. I mean, I guess they send an IT guy up there, and he's got to basically babysit us and make sure we don't jump over the edge, because you could easily do that, and some people have. So, May, let's see. We had a good turnout for MAD last weekend, and I had fun on 5760. We did that instead of 47 gig. And of course, now we're at May 9th meeting. Today is also the Central States Sprint that Scott put out a notice on. And that's tonight from 2300 to 0300 Zulu. And I guess, Scott, the rules are, what do you got to swap? Okay, 4-digit. Oh, you can do both? Okay, and they count. But I think if you go to centralstatesvhfsociety.org, you can probably see the rules. Okay. So check your email that Scott sent out this week. And also, next weekend is the Dubas 10.3 gigahertz EME contest. And it's sponsored by the Dubas magazine, which I highly recommend. The Dubas magazine comes out once a quarter, and there are different activity columns put on by different folks in different area. Tony Kate ZR is representing the U.S. and doing a very nice job of writing up about activity in the area. But some good reading. And I think KL7UW's wife, maybe it's Janet, she's the local one. Of course, she's up in Alaska, but she's the one we send our money to, and then Dubas comes directly from Germany 4 times a year. So good magazine. And they sponsor the EME contest. These are predominantly analog contests, no digital. But whenever they're, like on that particular weekend, you can check into the HB9Q logger, and you can kind of get some idea of the activity on the bands. So next weekend be 10.3. So look for some activity there. And if you want to see what the guys are running, just click on their call, and it'll show the equipment and the antenna, and you get some idea of what it takes to be successful. June, the first weekend, probably do a MAD again, right? And we talked about no meeting in June because it's the same weekend as the June VHF contest, and also the I don't know why I didn't put the DFW Hamfest in there, but that's also the same weekend. And also happens to be the same weekend as the 24 gig EME contest sponsored by Dubas. So it's a busy month. So I guess just to go over this, then I'll turn it back over to Jim. We have a local get-together that Al Webb and Ross and a couple other guys, Dave N5FU, check into, and that's 8 o'clock every Sunday night, 144-260. And Al, are you still calling the Hoot Owl Net on Sunday night? Or Saturday night, rather? Well, it'll start to go up even more with the sporadic E season. And we do meet every Tuesday at the Texas Smokehouse Barbecue. That hasn't changed in years. The only thing that changes it if it's a holiday or something like that. But we'll give you advance notice about that. And on these activity nights, these used to be pretty prevalent or pretty active back in the COVID days, because nobody got out, everybody stayed in, might as well get on the radio. So it was every Monday night, and it was actually 144, 174. And so that's probably in my mind, around here, there's more activity on digital than there is on phones. So I pretty much monitor 144, 174, but I monitor it all the time, and I think a lot of people monitor it all the time. The only thing that's you might see a little bit more activity with is the 220 night, because there's a group of folks up in the Midwest and the East Coast, including Dave K1WHS, that are promoting 222, both terrestrial and EME, and that's predominantly on Tuesday night. And Wednesday night is generally 432 and maybe and above. So we already talked about MAD, Microwave Activity Day. We changed ours to be the first Saturday of the month to kind of correspond with the Midwest group and other groups. Any questions about that or additions?
Are those vertical or horizontal polar?
No, these are all horizontal. Oh, yeah. Yeah, the only thing that's vertical around here would be the repeaters and whatever else goes on.
But if you get vertical, get on.
Turn it sideways. Put it on the ground plane, turn it sideways. All right.
Okay, let me sit there and I will make a fool of myself trying to get your presentation to go.
Okay.
Okay?
All right.
We're going to have to swap chairs.
All right. So you're going to switch from that?
Yeah, I'm going to shut that down. All right. Okay.
And Arturo has brought some snacks up here. You're welcome to share in.
Thank you. Okay, hang on, guys, while we go through.
Are a little in there. And but I think what we'd have to do is you got to make a plan for it. And I assume it's probably should be aluminum, and it's got to be TIG welded, I guess. And that's kind of out of my league. Jim's going to bring a sample to. Yeah, Matt got one. Okay. Oh, okay. Well, then we have to work on some flanges. So, but I've got that.
All right, you are set here, by the way. You're set here.
Yeah, maybe we talk to Mutz about making some flanges. Okay.
Well,
Put you on a deadline.
Yeah.
May have my drink over there.
out there in Zoom land, are you seeing the presentation, Periscope?
Negative. Just gotta probably reshare the screen or reshare the presentation.
Yeah. Okay.
Sit down.
Yeah, probably. Or just, yeah, I need to get closer for my eyes.
I think we'll probably send a couple of these home with Jim so he can take it over to Motts. Motts needs a project to kind of keep him busy.
How's it look now, David?
Looks
It's
good.
there?
Yeah, I can see it. Yep, looks great.
Got to remember to share. That's one of not remembering.
All right. The first time I talked about the Periscope antenna was around COVID days. In fact, I think it was in 2020. And I presented this presentation at the Southeast Conference. And I thought I'd represent it here. There's a couple of new items in there. And I thought I would share those with you. So I'll show you a picture of a periscope antenna if you don't know what it is. But first off, why use a periscope antenna? Well, the periscope antenna transmission line losses are eliminated or minimized. And sensitive electronics are all at the base of the tower, and you don't have to climb the tower. All three of which I care for. This is my periscope antenna. In fact, let me just go to this one here just to describe it. This is probably best. Let's see, can you see my cursor out there in radio land? Think they can see
I
that?
don't think so.
Okay. On the left, you can see there's an antenna on the ground that's aimed straight up and it reflects off of a reflector that's at a 45-degree angle. And of course, it gets sent out to the left, if you will, following the arrows. And you can see in the upper right is my Flyswatter, which is actually a decommissioned stop sign.
Sorry.
And down here,
Well, it looks like a stop sign, and then doesn't mean it was a stop sign.
oh, it was a stop sign. It was a stop sign. It was legally decommissioned and appropriated, I guess.
I love it.
So, and then I use the dishes at the bottom. I slide them on a support system. So let me just go back here. What I had thought about doing, this is my rotating tower, Rome 45 that I've got up. It's there's only 20-foot separation between these two rings, but there's 30 below the first ring. And my son and I put that up in 2015. And I've got all the VHF stuff up at the top. And with Joel Harrison's help, we got all that up. And I had hoped that in this in-between area here, shown with the second red arrow, is where the microwave dishes would be. And I decided, okay, the stop sign's got to be here. So that just kind of fixed my starting point, if you will. And in hindsight, I'm going to move that up another 20 foot. This is my existing microwave stuff over here. We've got 2, 3, 5, 10, and 24 on side mounted on this other tower. But that was my plan, and so my son Eric installed this second reflector that you see. And on that second reflector, but the reflector. I showed you this slide before. And here's a close-up of what Craig Young had built up. And actually, he used this on a fixed tower. So what he had to do was actually rotate the stop sign in azimuth. For me, it's fixed. I rotate my whole tower. And I've got an actuator for elevation. And the indicator has since gone kaput, so I don't vary the elevation of the Flyswatter. My son set it at 45 degrees with a digital level, and I know my tower's not perfect as I rotate it around, but it was what I had. It was what I was given. And here's a real Flyswatter. I don't know if this is still in use or not, but when you Google it, you find out that any systems that were in use can still be used, and I'm sure it's dependent on some location, but they won't issue any new licenses for these things. If you guys remember, going up on 75, US 75, just south of Sherman, maybe it was Sherman, up on the hill, there was a two Flyswatter thing, and one of them was aimed south, probably towards Dallas, and the other one was aimed north. So some sort of a relay system, if you will. And that's exactly what these guys are doing here. We got two reflectors, and we've got two source antennas. And I don't know where they're aimed, but these are down by Dublin, Texas. So they're still around. Now, what we need now is some way to calculate how we can use this thing on what frequency. And Paul Wade came up with this Periscope calculator years ago, and it's got some really high-techy stuff down here in the bottom which you don't mess with. I guess you could. It's an Excel spreadsheet, so I just downloaded it to my laptop. But the important stuff is up here in blue and in green. And if you go on to the next slide here, I just kind of blew this up a little bit. And you could spend all night doing this. It's all sorts of what ifs, if you will. So I picked 47 gigahertz. The dish diameter was 0.3, which is actually about a foot, 12 inches. The Flyswatter aperture, about 30 inches, 0.76 meter. And the spacing between the source antenna on the ground and the reflector is 13.7 meters, or about 45 feet. So it only puts this thing up maybe 50 some odd feet above the ground. And when you put in these parameters, it comes back with a suggested Flyswatter size. So basically it says my Flyswatter is a little too big for 47 gigahertz. And you'll see probably why it's showing that. But the other thing you look at is the system gain, dish gain, and feed line equivalent. So just remember that any RF is better than no RF. So the dish gain, 30-inch 12-inch dish on 47 gigahertz will have about 40 some odd dBi gain. With this Flyswatter not being optimum, my system gain is only 28 dB. So you could say that there was 12.8 dB of feed line loss. I lost 12 dB going from my source antenna up to the reflector because I chose a certain size reflector. As it turns out, the stop sign is too big for 47 gigahertz at that separation. But when you consider 28 dBi is better than no dBi. So the other interesting thing to do here is, and I'm sure some guys that are better than Excel than me could probably plot this stuff a lot easier. But if you look at that same Flyswatter, the 30-inch and 12-inch, 12-inch source antennas on 24 and 47 and 76. Oops. Oh boy. Sorry about that. With that same Flyswatter aperture and a slight variation in the source antenna, you can see the gain of the system. Look down here at the effective gain of Periscope. It's in yellow. 5760, it's the gain is like minus 3.2 dB. So that means if the dish gain's got 30 dB a gain, the system gains 27. It's still better than no dBi. But you go down here, it looks like at 24 gigahertz, you can actually get some gain out of that system. I have not used it on 24 gig yet. And on 47 gigahertz, unfortunately, it's minus 12 dB. That's what you've been working me on.
Yeah, but your height of that Flyswatter really matters, even though it's not optimum.
It's better than no RF.
Right.
And you can tell that in reality, it wanted to have a smaller source antenna. It wanted to have a 7-inch source antenna, and maybe I have a little bit more system gain. And I've used it on 76 to work across Lake Lavon, but that's the only context that I made. But really, the band that it works the poorest on is where I've had the most fun with it. So how does it work? Well, 78 gigahertz worked across Lake Lavon, and a whopping 24 kilometers. On 47 gigahertz, I worked 4 grids, worked Jim in 4 grids, 12, 13, 22, and 23, and a best DX of 121 kilometers, thanks to Jim. And plus having worked RW3BP in Moscow on EME, gave me a VUCC. As far as the equipment goes, I built my first transverter when I made that EME contact with Sergey. But since then, I've been using the Cooney units. And the Cooney units are still available. And You know, they're not cheap, but they save you a lot of effort. The Cooney 47 gig transverter, €815, subtract the VAT, and then add on some postage. It'll probably be about 700. Wait, 700. Yeah, probably 700 and some odd dollars. And then you got to buy the PLL. But this is the only game in town right now. It's the stuff by Cooney. And what's kind of scary, the last couple of times I've been to Cooney's website, you got to really look hard for amateur radio equipment. It's kind of like, since they got bought out by Alaris, I think it was, their emphasis is not on us anymore. It's on the commercial business. But I noticed it's up on the, if you Google Cooney, you'll see there's a link on the upper right-hand corner for the ham radio store, I think is what they call it. So I dread the day that we get the note that they're out of that business. Now, they don't build a half-watt amp anymore, and that's being driven by the fact that the devices are not that readily available anymore. So here's my 47 gig VUCC, happy to say. Got that back in December. I was happy about that. It took a lot of years.
That was number one, wasn't it?
Oh, no.
One? Oh, okay.
Oh, no. You give me too much credit, Al.
Okay.
22.
Well, that's good.
Yeah. In the top 25, right? But we're going for more. Oh, and you got a reverse VUCC.
No,
No, you got a VUCC.
I got a VUCC.
Yeah, Jim's got his VUCC as well in 47 and 70, 24.
Just to keep it flat.
Well, Craig built a pretty good platform for it. It's been up there for quite a few years. I guess if things could have slipped a little bit, I can't measure the elevation angle right now, so.
You just have to peak the elevation on your target, right? You move it up and down, or you just leave it there.
Oh, I just leave it there. Yeah. Yeah, since it's rotated on the ground with the rotor, the whole tower's rotating.
But do you have elevation on the Flyswatter?
There is elevation up there, but I don't have an indicator.
Yeah.
So I'm not going to move it.
Okay.
I guess I could, but if it goes one way and the squirrels ate the wire going the other way, that'd be in deep doo-doo. I know. I don't want to attract too much attention out there. All right, let me move forward here. And just another example here. When I tried the Flyswatter on 5760, I put in 5.7 gigahertz. I enter in the dish diameter, which was actually, I think it was a 30-inch dish, and a Flyswatter 0.8 spacing. And if you look at the different dish diameters, this is source antenna versus system gain, you can see that it likes to have a 3-foot dish feeding it. Now, the system can be more efficient with a smaller antenna, but it's got lower gain. So in my mind, you got to look at the overall gain of it. But sit down with it, just do some what ifs. It's a real friendly calculator. Got to put everything in there in meters, so you'll learn the conversion real quick. And this is this dish has been around the block. You can see it's a little cattywampus, as I say, but it's got a 5 and 10 gig feed in it. I haven't used it on 10 gig, but I do use it on 5 gigahertz. And I've got a Tractor Supply hail-proof cover over it, and that saved me a couple of times. The only downside is in the wintertime, the squirrels get in there and they build a home. So I take the dish down when I need to. And this is the system here. I use a bunch of waveguide. I got some WR137 rigid waveguide and some flex to get around the rotor loop. And my feed line loss is about 2.5 dB on 5760. But it does work. A year ago this month, I did work Buddy down in Florida with it. And you can see our very not so quiet band up here. You see a lot of Wi-Fi stuff. But when you look at it on WSJT, it's kind of like, okay, I can fit the WSJT signals in between those spurs. And WSJT is pretty forgiving. And it decoded a Q6530A signal from Buddy. And that's a 936 mile contact to out of Florida. And here you can see the transactions on WSJT. And yeah, we use digital quite a bit on terrestrial. And the guys down in Florida seem to be keen with using digital as well. Well, here's another interesting contact, K4VJ. I worked him as well. And turns out I worked him. His signal is actually, it's kind of hard to see, but you can actually look at the red. The green up here is where the sync signal is, and the red actually defines the bandwidth of the signal. And you don't see a lot of signal, and you can see it traverse on some of this Wi-Fi interference, but it's still, I was able to work him without a problem. And he's running the IC 905 rig. He's running the same rig that you're running right there. The 905, and how many watts on 5760? Half?
65.
Yeah, I don't think it's that high. Let's see. This is K4VJ's setup. This will blow your mind. IC 905 RF unit in the shack. 1.5 foot of RG142 to a 6-port latching relay. And keep in mind, this is on 5760. 3 feet a 1/2 inch hard line from the switch to a disconnect panel on the wall. 70 foot of LMR 600 to 80 feet of 7/8 hard line. The 2 pieces a 1/2 inch connected to a second relay at the base of the tower. And another relay, 55 feet of hard line. 17 dB of loss. So I dropped his 2 watts. I guess it runs 2 watts. Dropped his 2 watts down to 40 milliwatts, but it's better than no RF. So that was quite astonishing. That was a hell of a tropo. So what am I going to do next? I'm going to move the Flyswatter up 20 feet. Just going through the computer analysis, it looks like it's the best place to put a Flyswatter. And I may put a second one up because I can put, on a 3-sided tower, you could have 3 of them if you wanted to, and then you just offset the feed platforms. And the green heron rotor box you can easily offset it for 120 degree offsets. So that's what I have in mind. And this is the predicted performance, Jim. I say Jim because he's my partner in crime when he goes out. The system gain should be 39 dBi on 47 gigahertz. That's about 11 dB higher than the system gain with what I got now.
Nice.
Yeah. So in fact, it's what happens is there's a magical combination of separation between the source antenna and the reflector, and for that distance, there's an optimum reflector size. And as you go up another 20 foot, it doesn't seem to mind the bigger aperture, which kind of makes sense because the signal's kind of broadening out a little bit. So it's in the future. And just something, this is just kind of a short Flyswatter, if you will, at 20 feet. Say 20 foot's all you got, but 20 foot's better than being on the ground. You can get actually a little bit of effective periscope gain with a 12-inch dish and 20-foot separation. So just sit down some night when you got nothing better to do and play around with these what-ifs. And this is basically in the Paul Wade Antenna Handbook, online antenna handbook that you can Google it. The other thing, pointing accuracy, since my source antenna and the reflector are in sync, if you will, there's no real errors there. There's elevation error, but the biggest challenge is just for me to aim the downstairs antenna at the center of the reflector up top. I tried a laser pointer in the past. I had some hard time trying to get things set up, but I think I'd like to go back and revisit using a decent laser to try to make sure everything is synced up. And just to give you some idea, on 47 gigahertz, with the green heron box, if I'm off a degree, the signal will be down. So the 3 dB beam width is very narrow on 47 gigahertz with this arrangement. But I get pretty good repeatability with Jim, and I think when Jim goes out and he doesn't exactly peak where he should be, chances are he'll say the same thing out where he's at. So it's like there's some other medium out there or something else that we're reflecting off of. But I'm pretty happy with it. Any questions? No, hopefully you got something out of it and give you something to do some evening while you're sitting at the computer.
Great, thank you, Al.
Maybe next time you get one of those things in the slides
Yeah.
that we can sit where on it.
Yes. Well, I do need to move, though.
Yeah, it's not a bad idea, is it?
No. All right, so we will go on, and this time I'll remember to share. We'll probably go about 45 minutes into this next one and then take a short break. Says this next one is a little bit on the long side. And I wanted to kind of take a look at who all's here right now. There's 10 participants. Tony, K8ZR, has come in. Good afternoon, Tony. And
Got Charles in
and Charles Osborne, yeah, K4CSO.
duly noted.
Yes. Good, great to see you guys. Thank you for joining. Okay, I'm going to start this and then go back and share it. That's where I want to be. Okay. I think just going quite slow here. Okay. Okay, David, do you see the start, part 4?
Yep. looks
Okay,
good.
very good. Thank you. Thank you. Appreciate that. A lot could be said here. We're going to start with just a quick review, and this will be the last time we show this portion, but some of this content you may have seen, so we'll breeze through it fairly quick. Looking at the audience, I think other than a couple of folks have seen it already before. So here we go. In the beginning, there was these simple questions that we asked, and we asked them of Claude, which is an AI presence, one that I work with at the QRL, and have worked with it for quite a number of months. Some days it's all day, every day, for days and days at a time as we solve a problem. And the project took a big boost when Graham McIntire joined us, who's also a software engineer, as I am myself, had in-depth experience back-end server functionality. Plus, he owns a wireless internet service with multiple backhaul systems. And Joe Jureka, one of our NTMS club members, also joined us with some time in the past. Over the last couple of years, we have been sharing back and forth information as to how do these contacts happen, how in the world do they happen, and he had inputs and advice and analysis of the SKU-T plots that we shared. He's the senior meteorologist at the NWS Lubbock. And then Mike Lavelle, I listed him here because Mike holds the 122 gigahertz DX record. And Mike did this analysis and prediction the hard way. He did it manually. But the means and methods that he used, we would be discovering for ourselves and leveraging the power of AI and the speed of the modern computer. At this point, we have several servers that are handling the project, and they are generating heat. I anticipate we will have to fund some of this infrastructure in the future so that it's not just sitting there borne by one person. So the recap of part one is just to, we wanted to know the mechanism. We asked the questions. We evaluated the answers. Being that we were knowledgeable enough microwavers to, detect an error in the AI analysis as getting steered off course. And then following the initial analysis, we added additional contacts at 24 and 47 gigahertz, these being patterns that we wanted the model to be training on. And, it absorbed those and said, give me more. And, I'm seeing some correlation and so on and so forth. And that's all AI is. And if I can ever leave a statement with you today, is AI is just a pattern matching. That's all it is. And the more it gets in associated data that's near those patterns, the more it learns and the more it can expand. And that's what makes it learn. And so if I show it a picture of a gray elephant, and I say that's called an elephant, and then I say I'm putting a pink stripe down the side of the gray elephant, it goes, oh, okay, that's pink and that's the elephant, so it's a pink stripe on the elephant. And then if I show it 5 more elephants, and it says these are slightly different, you see it's beginning to train on comparable matching patterns but with deviations. And so the more of this goes on, the better its brain develops, if you want to call it a brain. It's really not. It's just a robotic computer matching game. It just does it in a big hurry. And the speed is what we need because it will take us a long time to manually do these predictions. This tool is now nationwide. It works across all the CONUS, and it's going to benefit a lot of people. So anyway, we're still back in the dark ages here, but it was going somewhere. We then added at the bottom bullet point the ASOS observations on the ground. At this point, we had 7 scoring elements and 4 actual contacts. This is an ASOS station on the left-hand side. They're sprinkled all over the U.S. This then expanded to these 7 scoring factors. I won't go into them because they've all been superseded or correlated. And you see in red over here, the very first thing, this is an original slide from a couple of months ago, after we had Graham on task, when we found 50,000 contacts that we could evaluate from the 10 gigahertz and up contests, we found very quickly that we had to flip some of these parameters around. And 10 gigahertz loved humidity so much that we had to adjust all kinds of thresholds. We built a map. This is the first of it that I built from an app, and it just color-coded the general conditions above the airport reporting stations here. These are airports. We added SKU-T plots. I'm not going to go into these definitions because we will go into them a little deeper later, but we added SKU-T plots, which gave us vertical indices so that we could see what was going on, at least at where the balloon took the measurement. Then, we started to emphasize the delta N over delta H gradient. This is the refractivity ability of the layers of atmosphere. And we have this statements in these last two bullet points that we've now got a much greater understanding of, but where the delta refractivity, which is N, the delta in refractivity over the delta in height, when it exceeds minus 157 per kilometer, we have ducting. The problem is I added this in parentheses recently because, yes, you have ducting as a result of this measurement through a balloon measurement, but it's at some altitude and it may not be useful for you. And so, that's another learning that we have. If it's 3 miles high, it was not going to help us unless we're on a mountain that's 3 miles high. So I added some additional applications, millimeter wavelength budget analyzer, which takes 2 points that you want to look at right now under current conditions, and then it'll predict the closure percentage, and it will show you the SKU-T plot that's closest to your path, and give you a better understanding. Then the prop analyzer was about inputting historical information. How did this contact? How was it achieved? And this then began to expand, the model itself, because we put in contacts that weren't already in the model. So this then became inputs to that model. The apps were complementary. This second bullet point, the SKU-T soundings, is from a radio sound balloon launch, but the GFS, what's called the GFS model forecast, is actually taking the SKU-T plot that's a given set of recordings right now, well, like one was launched at 6 a.m. In Fort Worth, and it forecasts from it using other data that it has, but basing its forecast on an initial statement at 6 a.m. this morning. So this is important, and that's what's explained here. The SKU-T through the GFS was spread out into the other apps. We're able to put a forecast button down on the bottom of one place here where we were able to forecast out to potentially 48 hours. Now, here's the first real use of what we had built. We were sitting there every morning looking at the application predictions and real-time data versus the experience that we were hearing. And Keith, WB5ZDP, put a report on the Slack page, the NTMS Slack channel, that said, hey, the 10 and 24 gigahertz beacons are 20 dB up from normal. So I spent a little more time studying the conditions, and what happened, go to the bottom bullet point, MAD was rained out on April the 4th. It was a heck of a rain that came through. It came through quickly and heavy, but the tool predictions for the 6th and the 7th started looking very favorable. And I mean, it started looking like we were going to have ground level duct potential. And so I got a hold of some people and we went out and did it. And so here are the results. I found two partners, one on the left here. This was Steve, K5MNZ, and he had just installed a new DEMI LNA on his 10 gigahertz rover, and he has a high spot back on one of his pastures. It's not much, but it's a little bit. You can see this terrible terrain blockage here, but he can get up about 20 feet above his house. He went back there in the pasture. I took up a spot over by Hillsboro, and we quickly completed with 599 signals. Just fantastic, strong signals, rover to rover, for a rover to rover 100-kilometer contact. But by now, Keith is waiting and ready up on Lake Lavon. He's up to the north side of Lake Lavon in Lavon, Texas, as they call it. And this was going to be a 129-click contact over a clearly blocked area, and it again, very strong signals. So this was a pat on the back of the tool. I was very happy with it. Now here is the breakdown, and there's some knowledge to be learned here. I'll take just a short minute to talk about it. The April 7th is at the top. This is the day of the contact, and there are green numbers. You won't be able to read their values, but over here on the right side, there are green numbers to the right of where it says April 7th, 7 a.m. The green numbers reflect the reason for the contact, and it is a very low duct. In fact, it's very hard to see. On the left side, the SKU-T plot has a band of gray that's right down on the deck. And that is the duct that we were traversing across DFW. There's a secondary duct that's up higher. It's more pronounced. The blue line is jagged back to the left quite a bit. That would be a temperature inversion compared to the red line, and which is, blue is dew point and red is temperature. So that diff is quite great there. That's going to be a temperature inversion. But down at the bottom is where we were taking the signal. Now the bottom chart is 4 days later when I made this slide, and it also had a very high green number in the upper right hand corner, which was dN over dH, which is the refractivity number. However, the look on the left where the inversion was, it was 3.5 miles high, getting battery low. I should have that in there. Sure hope I brought it. Stand by while we try to keep this alive. Has that got a brick in it? Or just that's an extension cord?
Extension cord.
I don't have so I guess we can. David, do you have a laptop power supply? A laptop power supply, which is a C
I got one for
cable? It's going to be a C. C.
That's why I don't have it with me right now.
Was it a USB-C? USB or whatever.
Wall wart. It's 24 volt.
I have my own car.
Okay. Mine is this.
No, that's not working. Hey, Scott's going to check to see if he has one. So I need to have a checklist next time, so I don't. Pretty important.
If you cannot find it, I have one, but I left it at the library. You can pick it up and come back. It's full service. You can find it.
Right.
It's not far, like 5 minutes.
5 minutes?
In case you don't find it.
Okay.
That's the one I was gonna use.
Yeah.
But I just got off that.
Well, it's going to need to be about 20 volts. Okay. Okay. Okay.
95 watts.
Yeah.
120. So
Won't need that much. Yeah. Okay. Well, I guess we'll go on until we hit the wall here, or we get Scott coming. Why don't you go ahead if you don't mind, and that way we'll. I mean, Scott went to get one, but so okay, good. All right, we'll flip a slide. So here's what I call the project acceleration rate here. So we went from creating things in March 1st. Graham joined at the end of the month. April 7th, we had our first successful contacts that I just showed a few minutes ago.
Got an adapter.
Well, that's the right, but I need 20 volts on the end of that.
Oh, geez.
Well, let's plug it in anyway.
Okay.
Okay. It might give us some help. Just put it right. Yeah. Okay. I don't know if we've got 5 volts going in where 20 should go in. We've got another fellow that's going to go back and fetch the proper power supply. So we'll go as far as we can. If we break off here, then I guess if you'll just wait, we will be back as soon as we have power.
Sounds good.
Okay, so the rest of this is, we had our Zoom meeting April 11th. Following the meeting, Graham reacted by adding quite a bit more, and this is now, if that was 10 dB, we've now seen another 10 dB since those days came along. May 2nd, here, this was just a couple weeks ago, we had our propagation predictions were confirmed. They were not great, but we did go out and experience about what was predicted, and we did get 24 gigahertz got better as the day went on. We got a surprise 24 gigahertz contact. Al and I did. So there's now a second algorithm was created around to learn from 58,000 contest QSOs, and a third algorithm is also on the wing, I call it, with some now at this point we've probably around 30,000 commercial link measurements. Those are all just like